Hi everyone, today we are going to start 2.2, which is analyze conditional statements. A conditional statement is a logical statement that has two parts, an if and a then. If part is called the hypothesis or antecedent. Then part is called the conclusion or the consequent. So here's our first example. If it is raining, then there are clouds in the sky. Which part would be the hypothesis, the if part? Well, it would be if it is raining, so this is the hypothesis. Which means the last part, then there are clouds in the sky, that would be the conclusion. Write as a conditional. All birds have feathers. So we want to write this statement as an if-then statement. So one example of this, all birds have feathers. If an animal is a bird, then it has feathers. So I'm going to write that. So if an animal is a bird, then it has feathers. Let's try this again with this next example. Every right angle is 90. So an if-then statement for this could be if an angle is a right angle, then it is 90 degrees. So I'm going to write that if an angle is a right angle, then it is 90 degrees. So for both these examples, all we did is we looked at the sentence and made it some type of if-then statement. If blah, 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 then blah, blah, blah. Negation. Negation is a statement that is the opposite of the original statement. So our first sentence here is the ball is red. How would I negate this? Well, we could just say the ball is not red. So I'll write that. The ball is not red. The cat is not black. How could I negate this? Well, we could say the cat is black. So the cat is black. So once again, I just negated these sentences. I made it opposite of what it was actually telling me. How about with some equations here? So my first one is an inequality. I have x plus 2 is greater than 10. How could I negate this? Well, one way is by flipping my inequality around. So x plus 2 is less than or equal to, because at the top one it's not equal to, 10. For the second part, x is equal to 5. How could I negate that? Well, we could just say x is not equal to 5. So our conditional statement, like we talked about, is an if-then statement. We're going to talk about a few other types of statements. The first one is a converse statement, and it's going to take our conditional statement and actually flip the P and the Q around. So back to the conditional statement, if P then Q, the converse would be if Q then P. An inverse statement is taking your conditional and negating it. So I'm going to draw an arrow. So we're taking this sentence and negating it. So conditional is if P then Q. Inverse would be if it is not P, then it is not Q. The contrapositive is actually going to take the inverse and flip the P and Q around. So if I'm going to draw another arrow here to kind of show you the difference. So if it is not Q, then it is not P. Now you may be looking at this chart and saying, what the heck are you talking about? Once we start getting into some actual sentences, this will make complete sense. But I would write this down in your notes somewhere because you're going to have to be able to mix the P and Q statements around depending on if it's a conditional, converse, inverse, or contrapositive. All right, so here's our first example. So our conditional statement, our if-then statement is, if the shape is a triangle, then it has 3 sides. What I want to do first is I want to actually underline my 2 sentences, the P and the Q. So remember, conditional is if P, so I have if the shape is a triangle, so that is going to be P. Sorry, it's really hard to write with this. That's supposed to be a P. Let me erase and try that again. Then Q, we have then it has 3 sides, so it has 3 sides is going to be our Q. I'm then going to write my converse. So if you look at your little chart from the previous slide, the converse was taking the P and the Q and flipping it around. So I'm going to have if Q, which Q is it has 3 sides, so if it has 3 sides, then our P statement, which the P statement is the shape is a triangle. So the shape is a triangle. So once again, going from my conditional to converse statement, just looking at the sentences, I just switched around my P statement and my Q statement. All right, now let's move to the inverse. The inverse is taking our conditional, the original, and negating the P and Q statement. So if our conditional is, if the shape is a triangle, if I want to negate that sentence, we'd have to say, if the shape is not a triangle. So that's what I'm going to write here. So if the shape is not a triangle. Now I need to look at the second part of my conditional statement, and I'm going to negate that. So then it has 3 sides. Negating that would be then it does not have 3 sides. And I'm going to write that down now. So then it does not have 3 sides. So let me explain that one more time. The inverse is taking our conditional statements and negating it. So my inverse is, if the shape is not a triangle, then it does not have 3 sides. The last sentence structure is a contrapositive. Now the contrapositive is going to take what my inverse sentence is and flip the P and Q statements around. So in other words, I'm just going to switch those 2 sentences. So my inverse is, if the shape is not a triangle, then it does not have 3 sides. The contrapositive then is going to be, if it does not have 3 sides, because that's the last part of my inverse, it's going to be the first part of the contrapositive. So if it does not have 3 sides, then, and we're going to go back to the first part of my inverse, the shape is not a triangle. So then the shape is not a triangle. And we're done. So we're going to do the similar thing for this slide, except for now, other than like a long sentence, we have math going on. So our conditional statement is if x is equal to 3, then x plus 5 is greater than 7. So x is equal to 3 is going to be my P statement. X plus 5 is greater than 7 is my Q statement. So remember, for the converse, I'm just going to look at my conditional, look at the P and Q statement, and I'm just going to flip them around. So the converse would then be if x plus 5 is greater than 7, then x is equal to 3. The inverse is going to look at my conditional statement and negate it. So the inverse would then be if x is not equal to 3, then x plus 5 is less than or equal to 7. And finally, the contrapositive is taking my inverse sentence and flipping those two sentences around. So if x plus 5 is less than or equal to 7, then x does not equal 3. And I'm done. Equivalent statements. When two statements are both true and false, they have the same truth value. So conditional and contrapositive statements are equivalent statements, and a converse and an inverse are equivalent statements. This isn't too important, so I wouldn't really focus on this. This is more of a side note. A biconditional statement. When the conditional and the converse are both true, you can create a single statement. And these are known as if and only if statements. You may also, instead of writing if and only if, you may see this, an if with two F's. That means if and only if. All right, so here is our conditional. So if A is 90 degrees, then it is a right angle. Is that statement true? It is. The converse is if A is a right angle, then it is equal to 90 degrees. Is that statement true? It is. So since both the conditional and the converse statements are true statements, you can then create a biconditional statement. And the biconditional statement is combining these two together and saying if A is equal to 90 degrees, if and only if it is a right angle. So A is equal to 90 degrees, if and only if it is a right angle. So all good definitions can be written as biconditional statements. So for this last problem here, we have two statements, and we're going to write the following as a biconditional statement. So number one, a pentagon is a polygon that has 5 sides. So how can we write this as an if and only if statement? Well, we could write it as a shape is a pentagon if and only if it has 5 sides. Both of those are true. A pentagon has 5 sides. So a shape is a pentagon if and only if it has 5 sides. For our second statement here, our statement is if Christy has an A, then she can go to the football game. If Christy can go to the football game, then she has an A. So I can then write this as a conditional statement because I have two statements here that are both true. If Christy has an A, she can go to the football game. If she was able to go to the football game, then she had an A. So to write this as an if and only if statement, I can say Christy. So Christy can go to the football game if and only if. Remember, you can write it like this if you don't want to write all those words. If and only if she has an A. And that's it.